In this section, we are looking in angular motion. A rotating disk accelerate uniform from 20 revolution per minute and 500 revolution per minute during 3 seconds. We are required to calculate angular acceleration, average angular velocity, angular displacement during 3 seconds and the number of revolutions. Here we are given revolution per minute. We convert them to revolution per second. Note, we represent revolution by letter n, which mean this is n1 and this is n2. Let us convert. n1 is equal to 20 revolution over 1 minute multiplied by minute over 60 seconds, we get 0.33 revolution per second. We do the same on n2 to get 8.33 revolution per second. The angular acceleration is calculated from this formula. On this formula, this angular acceleration must be a subject of the formula like this. Or you may expand the angular velocity like this. But let us use this for extended information. For this formula, we will first calculate initial angular velocity and also the final velocity. We say, initial angular velocity is equal to 2 pi times n1. That is 2 pi times 0.33, which give us 2.07 radians per second. Final angular velocity equals 2 pi times n2. That is 2 pi times 8.33, which give us 52.34 radians per second. Because now we have this information, we say, angular acceleration formula equals 52.34 minus 2.07 all divided by 3. We get angular acceleration to be 16.76 radians per second square. Now we have to find average angular velocity, that is what the statement said. For average angular velocity, we just take initial and final angular velocity, add them together like this and all divided by 2. That is 2.07 plus 52.34 all divided by 2. We get average angular velocity to be 27.21 radians per second. Now we find angular displacement from this formula. What you must notice about this formula is this part, which is angular average velocity that we just got now. So without wasting time, just take its value and pluck on here and proceed. That is 27.21 times 3. We get angular displacement to be 81.62 radians. Note, this angular displacement formula is also written like this. But I prefer to write it like this. It is still gonna give you same answer. Now we calculate number of revolutions. We simple add together n1 and n2 all divided by 2. That is 0.33 plus 8.33 all divided by 2. We get 4.33 revolutions per second. Then we say, for 0.33 revolution per second times 3 seconds, we get number of revolutions to be 12.99 revolutions. Note, this is for average number of revolutions per second, which helped us to find number of average revolutions per second, which then we multiply by time given to get an exact number of revolutions.